So in this lab, we're going to be doing a few more example t-tests. Now, in another video that I previously put up, we did independent sample t-tests. That's where you test for mean differences between two groups. In this one, however, we're going to be looking at one group of participants over time. So this is when you'd actually use a paired sample t-test. So let me explain this data file a little bit. It's an experiment I did in grad school. This was with UC Davis students. It has a pretty good amount of data collected, so about, looks like almost 300 data points. But this is just a little online study that I did. So with this one, basically I took two measures, one at baseline and one during a treatment phase of two personality variables. So the big 5C is for conscientiousness. This personality variable is basically how hardworking someone is, how much someone prepares for the future, how prepared people are for things, that sort of thing. It's a very general personality characteristic that tends to be pretty consistent over time. So we'll talk about neuroticism here in a sec. Let's just stick with conscientiousness. So one of the things I was interested in is, do people change the way they view themselves, their own personality, to sort of assuage stress, especially maybe stress from a social cause. So what I did was I took a bunch of undergraduates, so about 300, that was what we saw, and when they first started the semester, they all took a conscientiousness and neuroticism, but basically a big 5 inventory to get all these personality traits. So then a few weeks later, and they didn't know that this was part of the same study, but a few weeks later, I had them come in and they all read a report that was from New York Times talking about the competitiveness of the job market. And this was back in the mid-2000s, so things were actually even worse than they are now. Actually, it's towards the late 2000s, right before 2010, so things were pretty bad at that point. And what I wanted to see is if people perhaps can make themselves less anxious about the job market by making themselves feel like they're more conscientious, that they're more hardworking, industrious, prolific, all that kind of stuff. So conscientiousness is one of those things that's been shown to be very stable across the lifespan, so it's not likely that they would actually increase in conscientiousness or decrease in the matter of a couple of weeks. But I figured that it would be possible that people could think of themselves as being more conscientious as a way to sort of make themselves feel better about, like, for example, a threatening job market. So basically, can people change their personality style, or at least the awareness of their own personality style or perception of it, in a way that combats social anxiety? So that was one measure that it was of conscientiousness. The hypothesis was basically that after they learned about the tough job market, they would artificially increase their conscientiousness scores, in the treatment condition. I did the same thing with neuroticism to see if maybe this would help them deal with anxiety, because what you would expect, and neuroticism, I should say, is a measure basically of depression and anxiety and negative affect. What you would expect is that the article, which is kind of a bummer for college students graduating at the time, should be increasing their neuroticism. But a lot of people have hypothesized that people are much more willing to do sort of mental gymnastics and self-delusional tricks, cognitive tricks, to basically maintain a low neuroticism level. So I hypothesized basically that they were going to up their conscientiousness as a way to make sure that the neuroticism doesn't actually increase, that they don't get anxious about the job market. And this was one variable that I thought might moderate this effect, basically their current university GPA. So I figured for really high up there students who were legitimately getting good grades and had a good job outlook, that they wouldn't need to up their conscientiousness that much in order to not feel anxious, because basically they were doing well at college, so they had a good idea that they'd probably do well outside of college. Whereas those with maybe lower GPAs, I thought they would probably be the ones that would more up their conscientiousness level, just as a way to, again, deal with that anxiety that maybe they're not going to be very competitive out in the job market. So I made this little variable here, basically just asking for their high school GPA, and then I partitioned it into two variables. I'll show you the variables here. One, basically, if they had a below a 3.0, and group 2, if they had above a 3.0. So it's sort of an arbitrary cutoff, but 3.0 is right about where I saw for the mean of the sample. And usually we think of anything above a 3.0 as being pretty good, anything below as being not so good. So I thought that was a pretty good cutoff. Okay, so now let's actually get into the statistics. So the first thing that we could be interested in is just, and we'll just look at the data here. So these are their conscientiousness scores. It's on a scale from 1 to 5, 1 meaning low conscientiousness, 5 meaning high. Same thing with neuroticism. So we have a lot of variability here, but let's see if that manipulation actually changed their conscientiousness scores from week 1 to week 2. So for example, this person scored exactly the same both weeks. This person seems to have gone up a little bit, as well as this person. So some people are increasing. This person actually decreased their score a little bit. This person increased it quite a bit. So on average, is there a significant increase due to this article that they read, due to the manipulation? So to do this, we want to go to Analyze, Compare Means. That's where all the t-tests are. And since this is one group of participants that have been measured across times, we call that a paired sample. So basically, the sample at the beginning is paired with the sample, it's the exact same sample, but the sample measurement at the end of the experiment. So go ahead and click on Paired Sample t-test. And so it asks you, okay, what's your pair is basically the same sample group. Variable 1 is going to be at time 1, and variable 2 is going to be at time 2. So it's pretty easy to fill it in. You just go big 5C, this is their initial conscientiousness score, that's going to go in variable 1. And then here in variable 2, or basically time 2, we're going to put big 5C week 2. Now, a really cool thing about this is it sets it up so you can actually run multiple comparisons. So let's go ahead and do that. So we expect that they go up in conscientiousness from time 1 to time 2. We don't expect that they'll go up in neuroticism because their increase in conscientiousness should counteract that. So we'll go ahead and put that in for time 1 and time 2 as well. So let me blow this up a little bit so you can see that basically we have week 1 here, week 2 here, in both conditions. And actually these were separated by more than a few weeks. So okay, let me just do a quick check here. No, nothing we need to change there. So that's it. So we can just click OK. And we can see if these are significant increases, decreases, or non-significant change across this time. So we click OK. Of course, we're doing 2 statistical tests at the same time, but we'll sort of break this up a little bit. So let's just pay attention to the conscientiousness first. So we have conscientiousness at baseline and conscientiousness at treatment. And on average, at baseline, people were about a 3.3 on a 5-point scale. And it looks like they did, in fact, go up a bit. So reading that manipulation article, it seems they went up to about a 3.6. So not a great change, only about a difference of 0.3 on a 5-point scale, which I guess would be about maybe a 5 to 6% change. But let's see if it's actually significant. So we basically are going to ignore this paired sample correlations table. This doesn't really reveal anything interesting for us. We're going to jump down here. So with the paired sample t-test, you actually don't do any Levene's test. And that's because the distributions of both groups, it doesn't matter if they're the same because it's literally coming from the exact same participant. So you don't need to control for different distributions for both groups. So again, let's just look at pair 1. This is comparing conscientiousness baseline to conscientiousness treatment. This is the mean difference. Again, doesn't really matter that it's negative. Basically, they changed about this much on average. Standard deviation of the difference, all that kind of stuff. But what we're really interested in, all the way down here, is significance two-tailed. So just like in the independent samples t-test, that's that's the statistic that we're interested in. So is this at or below 0.05? It indeed is. It's well below 0.05. So basically, we did find that in terms of conscientiousness, they actually did basically increase their conscientiousness scores significantly. So for example, if we're going to write that up, let me get a little Word document going on here and shrink it down so we can kind of see this all at the same time. So you could say something like, for example, results of a paired sample t-test showed that participants were significantly higher in conscientiousness going from baseline to after the manipulation. And again, you can kind of write that in any which way you want to. This just sort of makes sense for me. But you could say something like there was a significant increase from baseline conscientiousness scores to manipulation conscientiousness scores, or post-measure conscientiousness scores. Whatever you want to say is fine as long as it makes sense. So that's our basic sense. And of course, we have to put in the means and standard deviations for our groups. So there we go. So it's the results, the paired sample, blah, 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 significantly higher in consciousness going from baseline. And I'll put in the mean and standard deviation here. So mean was 3.34. Actually, we round up because basically 7 makes that a 5, and that makes that a 4. and SD 0.53. Now remember to put in the 0 for SD. The only time you don't put in zeros are for correlations and p-values. Every other time you want to put in a 0 if it starts with 1. All right, and then we'll make this actually a little bit, read a little bit better. So in consciousness scores going from the baseline period to after the, or I'll just say to the post manipulation period. I'm making it a little bit more wordy, but just because we're sort of cutting the sentence in two with this part, I want to make sure that people are getting to a complete thought here, then the mean standard deviation, and then the next complete thought. Okay, so then we can just put in the mean standard deviation for the treatment condition, which it shows right here is 3.57. SD equals 0.64. Yes, okay. And then we want to put in, of course, the t-statistics, just like we did with the independent t-test. So put a little comma here, t, since it's a t-test. The DF is displayed right here, 282. And then the t signal, or the t value right here is, it says negative 4.897, but we always want to make t values positive, same with f values when we get to that. So we're just going to put in 4.90, so we're going to round to the 100th place. And this is something that's a little particular to AP formatting, but you can never say, for example, you can never put in p equals 0.000, because you can never say that the probability of type 1 error is perfectly 0. We can never be absolutely sure. So what we do, if we get this reading in SPSS, and really if we double click on it, it'll eventually show us, we double click on it like this, it'll eventually show us it's actually 0.000002. It's very unlikely that this isn't a real effect, but still it's not 0. But you can close that. So the way we deal with that in APA formatting is just we say p is less than 0.001. Basically, it's really, really tiny. Okay, so you can even cap it off, you know, a figure 1 if you had a figure or whatever. But basically, that's the results sentence. The only thing left to do is just italicize all of the statistical acronyms. So the means, standard deviation, the t for t-value, oops, there we go, and the p for p-value. And also notice that we have spaces between each text element. You know, the equal signs, less than sign, there's a space between all the elements there. Okay, so that's one result. I'll go over this one a little more quickly, and I won't write up this one because it's pretty much the exact same thing. So my hypothesis was actually that neuroticism wouldn't increase because you'd have consciousness increasing basically to alleviate anxiety that that article might cause. But actually it did increase a little bit here. So not as much as conscientiousness did, but it went from, well, about a 3.5 to 3.5 if you round it, but a 3.47 to a 3.54. So it is a very small difference here. And actually you can see the difference right here was only 0.075. So it's a really tiny difference. But again, what matters, was this difference statistically significant? Meaning, even though it's a really tiny difference between groups, is it more than we could expect just from chance fluctuations in the data or chance findings? And actually it is. So this is a small but reliable finding. So you'd want to write that up. Again, this goes against my hypothesis, but it's a significant finding, so you'd want to report it as such. So you can go, you know, contrary to hypotheses, there was still a significant difference in neuroticism going up from baseline to treatment, or whatever you want to put that. Okay, so that's the basics of a paired sample t-test. It's kind of cool. You can run multiple comparisons there if you want to do that. So the other type, well, actually, let me show you real quick how to graph this. That's a very important thing. So if you want to graph, for example, the change between conscientiousness scores from time 1 or baseline to time 2, the treatment, the best way to do that is actually a line graph. We could do a bar graph where we show basically 1 bar for time 1, 1 bar for time 2, but a line graph kind of makes more sense because you're talking about gradual change over time, and a line sort of shows that all the dots are connected. So we're going to go to line graph, and we're going to do something a little different here. We're going to still keep it a simple line graph, but instead of going summaries for groups of cases, we're going to go summaries of separate variables. That's because these are totally separate variables, but we want them both included in the graph. If we clicked on summary for groups of cases, we could really only have one of these variables with its mean. So we're going to go summaries of separate variables. Click define. Oh, actually I already put it in there. Let me just reset it to show you though. So basically it's as easy as, what does your line represent? Well, it represents the time between conscientiousness of time 1 to conscientiousness of time 2. Now, if you go to change statistic, you can put in any kind of measure of these two variables that you want, but we're just looking for mean differences. So right here, it's perfectly good at mean of values. It's very rare that you'd actually change this, but sometimes people prefer to display the median or the mode for different statistical reasons. But mean is pretty much always what we're going to do. In fact, I will dare say it is what we're always going to do in this class. So then the last thing you want to do is go up to Options and click Display Error Bars. So this will display on the graph whether or not time 1 is significantly different in its mean than time 2. So go ahead and click Continue. And that's it. You got your variables in. They're displaying means. Got your error bars in there. So go ahead and click OK. And as you can see here, it draws up a nice graph for you. Here's conscientiousness at baseline. Sorry, I have a really tough time saying that word fast. Here's conscientiousness during the treatment period. You can see it's going up because of that article. That's basically the reason why. That's a manipulation. And since there's no overlap between these error bars, you can basically draw a straight line through here and not run into either error bar. We can be sure that this is in fact a significant effect, or it just displays that fact in the graph itself. Of course, we did a t-test to already show that. Now, if we do this with let me just run this again with the neuroticism. So let me kick these two out and then put in the neuroticism. Should still include the error bars and everything. We'll click OK. This actually shows that there shouldn't be any significant difference in the neuroticism score, but like we discussed, sometimes there is a significant difference that's just not displayed in the graph. Again, creating these error bars uses slightly different mathematics than calculating the significance for a specific t-test, because these graphs have to work for many, many different types of tests. So again, you want to graph it, but just because a graph doesn't show a significant effect doesn't necessarily mean it's not significant. Okay, so that's on the paired sample t-test. There's only one other t-test I want to show you. It's not one that psychologists use a ton, but it can be a good way to compare your group, to compare your sample rather, to see if it's representative of a population or of the average person. And so what we're going to do here with this big 5C and big 5N, these are personality variables, part of the big 5 inventory that get used a ton in national samples all the time. They're sort of the top 5 most studied personality factors. And so each year, or every few years, they recalibrate the test, or they recalibrate the scale so that the national average is a perfect 3 out of 5, or right in the middle, because that's what you'd expect for personalities, that most people are going to clump around the middle. So just like the IQ test, they periodically revamp it so that the average across the nation is a 3. So let's go ahead and see. We can use what's called a one-sample t-test. So if you go to Analyze, Compare Means One-Sample t-test. What this t-test will tell us is if our mean of these scores, or really of any score, we're going to pick on conscientiousness first, if our mean conscientiousness score is significantly different in our sample from that of the national average, which is set at 3. So go to one sample t-test. We're going to plug in big 5 conscientiousness, and actually we'll go ahead and plug this one in as well, because the mean for big 5 in or neuroticism is also set at 3. All of the personality variables are. They're set right at the midpoint of 3 out of 5. So this is the value, the test value of what you compare them to see if they're significantly different from this, or the mean scores are significantly different in your sample. And as I said, this is a 3. So this is the value that you're going to be changing according to maybe what your national standards say. So for example, if we were measuring height of our sample of men, well, let's say we measured in inches. We know that in the US, men on average are 5'9" or 69 inches. So you do is you put in height here and you put in a 69 for the test variable. See if your sample is significantly different from that. If you're measuring IQ of your sample, we know, because this is again, the IQ test is re-standardized from year to year so that the national average is right at 100. We could put in the IQ of our sample right here, and then right here put in the test value of 100 to see if we're significantly different from that. So really, you always want to put in a test value that makes sense for what you're measuring. And again, this is usually only the case if you have a really good estimate of what the average population actually is in that variable, which doesn't happen often. All right, so we're not missing anything there. So basically just click OK. This is a really quick and easy test, but let me show you how to interpret it. So here we go. So our mean conscientiousness, and again, this is at baseline, so it's not being manipulated at all. And our mean neuroticism scores are both actually higher than you would expect from the national average. So national average is about a 3. It looks like, and this is kind of no surprise, that college students are a little bit higher in conscientiousness of hardworking, being prepared, all that stuff, than the national average, which of course includes non-college students. But they also seem to be a bit higher, even more higher comparatively, in neuroticism. So actually college students might actually be higher in anxiety, depression, or at least more self-reporting of those types of emotions than the national sample. So that again, we don't necessarily say that this is what matters. What really matters is this difference actually significant? And here we go again, sig, two-tailed. You're always looking for this sign when it comes to t-tests. And in fact, both of these are significantly different. So you can say that basically this college sample is not the most representative sample of the general population because they are significantly higher in both conscientiousness and neuroticism scores. And you would report that very similarly to how you do with any type of t-test. Here, let me scrunch this up a little bit so I can get it all on one screen. There we go. So you'd say something like, our sample was significantly higher in conscientiousness, and you can put in sort of the mean for our sample, mean of 3.34, and SD of 0.53. And we put in here compared to the national average, which we could put in as a mean equals 3. And I'm not sure what the SD of our sample or of the national average is. It doesn't really matter for this test. You might want to put that in if you knew it, but it's perfectly fine not to with a one sample t-test because it doesn't matter for the statistics involved. And then you would again say this is a t-test, so a little t-value. You look for the DF value. Here it's 282. And then our t-value right here equals, it's a very big t-value, it's very significant, 10.60. And then again, p equals 0.000. It's probably a really long run of zeros before you get to a non-zero. But again, we're just going to write in p equals less than 0.001. And we could write up the same thing for neuroticism in a similar sentence. And again, you just would want to italicize, you know, all of the, here, I'll just do that, all of the little statistical acronyms. I won't do it right now because you kind of follow that part, I'm sure. So there's no real way to, or no preferred way to graph this information. If you wanted to graph it in some way, you can do what's called a box plot graph. This would basically show, actually an error bar graph would probably even be better. This would just show what the average for the group is in the 95% confidence interval where they are. So if the 95% confidence interval is not sort of including 3.0 or the national average, then you know it's significantly different from the national average. In fact, let's go ahead and do that right now. It's a very easy graph. It's just going to be simple summaries for separate variables here. And again, you just want to put in, we can just put in big 5C and go ahead and just put in big 5N. Our confidence intervals are set for 95% around the mean, which is perfect. I don't think there's anything to do here. No, because we're displaying error bars. Hopefully, that's the whole purpose of this graph. So we'll go and click OK, and there they are. So basically, as you can see, you know, this graph only goes down to 3.25. That our best guesstimate as to the actual college samples, you know, conscientiousness scores, that's on this side, is somewhere between a 3.27, it looks like, and about a 3.4. So obviously, that's above 3. So we're 95% confident that this group is significantly higher than a 3 or the national average, and it's even more so for neuroticism. In fact, you can even compare these. These don't look like they're overlapping, so it's probably safe to say that this group is actually significantly higher in neuroticism than they are in conscientiousness. Sort of an interesting little side finding. So another thing I wanted to highlight was this little experiment, or part of the experiment I looked at as moderating the effect of the article on conscientiousness going from time 1 to time 2. So like I was saying before, I kind of figured that people with a higher GPA, so I put it here as above a 3.0, wouldn't need to probably up their conscientiousness as much as those with a lower GPA, because those with a lower GPA would probably have more anxiety about the job market. So I'm not really going to show you how to do analysis of that quite yet. That gets into a mixed model approach and would probably require an ANOVA to really figure out statistically. But I just wanted to show you a quick graphic technique to just look at this change from time 1 to time 2 in conscientiousness broken up between these two groups to see if these two groups show a difference in this change. So one way you can do this, kind of the easiest way to do this, is to split the file. So what this is going to do is whatever type of, honestly it's already here, let me just reset this to show you. So basically what it's going to do is whatever type of analysis we do on, it could be a repeated measures t-test, could just be a graph, what it'll do is it'll produce two of them if we do compare groups, and then we put in this GPA high-low. This is, of course, above 3.0 or below 3.0 right here. So it'll do two analyses, one for the below 3.0 group and one for the above 3.0 group. So this is one way we can sort of test to see if these two groups are different in the way they're changing from time 1 to time 2 with a big 5C. So this is a bit of an interaction. It's getting a little bit ahead of ourselves. We'll get to this when we get to ANOVA, but it's just something I wanted to show you as part of how you can do repeated measures ANOVA. So go ahead and click OK there. And you're not going to see any real difference in the output or anything like that. You're not going to see any difference here. Basically, it'll just yield two outputs from now on. So let's go ahead and do, let's see, analyze, compare means or paired sample t-tests here. Let's go ahead and just kick these out. I don't want to get too confusing because we're already going to get two outputs for one of these as it is, but now we're just going to compare time 1 conscientiousness to time 2 conscientiousness. So go ahead and click OK. And again, we're going to get two outputs for this. And one is going to be for people below 3.0, and one's going to be people for above a 3.0. It actually also split it up with this one missing data point. I'm not quite sure how that got in there, but we can just ignore that. If they come up periods, it basically just means missing data. So you can see here, from people below 3.0, they actually made a pretty big gain in conscientiousness from time 1 to time 2. So they went up about 0.4 points. Actually, you can see right here the mean difference is 0.4 from time 1 to time 2. Which, compared to this group, those above a 3.0 didn't seem to make nearly as big a gain. In fact, their mean difference was only 0.9. So again, that sort of goes along with the hypothesis that this group's going to be making bigger gains due to deal with anxiety about maybe not being competitive on the job market compared to this group who is doing better in school. But let's see which ones may or may not be significant. So again, you want to go here and go all the way to sig two-tailed. And this first pair, time 1 and time 2 consciousness, just with below the 3.0 people, turns out that was indeed a significant effect, just like we saw before with the general sample. But actually for those above a 3.0, they didn't have any significant change in conscientiousness scores. So this did, in fact, moderate that effect. So again, this is not at or below 0.05. So we say this is not significantly different from time 1 to time 2. So this really went along with the hypothesis that it's only people who had a lower GPA who made this sort of conscious concession or misperception of themselves as being more conscientious in order to make themselves feel better about the competitive job market. Those who had a high GPA didn't nearly feel the need to do that. There wasn't a significant difference there. And the same can be done in making a line graph from time 1 to time 2. Again, you just want to go to graphs line. We want to keep simple, keep all the other settings we have here, and in fact just go ahead and, well actually we're going to kick out this and put in the conscientious one, because that's one we're interested in here. We're going to keep everything else the same. It's the mean. Should be, oh, this wasn't turned on, display error bars. We've got to have that on. So click continue. Go ahead and click OK. And again, we're going to get two graphs here. One is for those below a 3.0, which you see this big increase on, very significant difference, no overlap between the error bars, going from about a 3.2 all the way to a 3.6. And then in this group, those at or above a 3.0, we don't see any significant difference here. Now again, if we just graph this, we wouldn't be able to rely on it because sometimes a non-significant effect on a graph will turn out to be significant in the paired sample t-test, but we know for sure by running the t-test that this is not a significant difference. So there you go. Now, this is a moderator in that this one variable, GPA, affects the relationship between another independent variable, in this case, the newspaper report that they read about the tough job market on the DV, which is conscientiousness score. So you see this big jump for people below 3.0 in GPA and no significant jump for people at or above a 3.0 in GPA. So we can do the same thing for neuroticism. But basically, I'll cut to the chase. We find the same exact thing with neuroticism. That people's neuroticism scores also didn't increase if they were at or below, or sorry, at or above a 3.0. So again, this is below 3.0. I just want to point that on the graph. It'll say here the variable above or below 3.0. This group is below 3.0. This group is above 3.0. Okay, so basically you can run sort of an interaction test with a paired sample t-test. A better way to do that would be with a repeated measures ANOVA, which we'll cover later, but I just wanted to show you that you can do that with a t-test as well.